Use the given graph in order to graph g of x, which is equal to negative 1/2 f of x minus 1 plus 3. Whenever we have a function and it has a lot of shifts, we tend to follow a specific order. And this order goes like this. First, we're going to shift horizontally. After that, we're going to stretch or shrink. Then we're going to reflect. And at the end, we're going to do the vertical shift. Now, here I have the general form of a function. And here's what all of the shifts do. So inside of the function, we have this h value that determines if we go left or right. Then this a value determines if my function is going to stretch or shrink. The reflections are dependent on what I have in front of f. If I have a negative, it's going to reflect over x. If I have a negative inside of the function, it's going to reflect over y. Then the k value dictates if I go up or down. So let's begin by moving this graph around, doing this or following this specific order. So let's begin by getting the horizontal shift. My h value is 1, so that tells me that I have to move to the right 1 unit. I'm going to grab all of my key points. So here, that's these x-intercepts, this edge, the origin, and this maximum of my parabolic section. So I'm going to go ahead and emphasize these. And now I'm going to begin to transition each one of them 1 unit to the right. So here I have my point A, here I have my point B, my point C, my point E, and my point D. Now if I follow the same pattern or the same structure of the original graph, I know that A, B, and C have to have a parabolic shape, and then at C is when I begin to do the straight lines, the linear sections. And here is my graph shifted 1 unit to the right. That's the first thing that I have to do. The next thing that I have to do is look at the stretch and the shrink, and that's going to depend on my a value. Here I have a negative 1/2. Since I have a negative, I also know that I'm going to begin reflecting this over the x-axis. So I'm actually going to do step 3 as well, which would be the reflection. So again, I'm going to do the stretch, the shrink, and the reflection at the same time. So I'm going to get the coordinates of each one of these points. So here, my a value is at -3, 0. So that's a. My b value is going to be at -1, 1, 2, 3, 4. My c value is at the point 1, 0. My e value is at 1, 2, 3, -2. And finally, d is at 5, 0. Here, in order to get the stretch or the shrink, I'm going to multiply each of the y coordinates by this -1/2. So I'm going to get 0 multiplied by -1/2, 4 multiplied by -1/2, all of these. My x values are going to remain the same. So here I'm going to get a prime, b prime, c prime, e prime, and d prime. And all of my x values are going to remain the same. So I'm going to begin to record them. And now I just have to transform. And now I just have to transform the y values by multiplying them by the -1/2. So 0 times -1/2, we're going to get 0. Here, if I get 4 and multiply it by -1/2, I'm going to get that -2. 0 multiplied by -1/2, we're going to get 0. -2 multiplied by -1/2, we're going to get a +1. And then 0 multiplied by -1/2, we're going to get 0. Now that I have all of my shifts here, or now that I've multiplied each one of these coordinates by that scalar, I'm going to begin to plot these new points. So let's begin with a prime. So a prime is going to be at -3, 0. So that one does not move. So that's A prime. B prime is at -1, -2. So at -1, I'm going to go down 2 units. Next, I'm going to grab C prime, which is at 1, 0. So that one doesn't change either. I'm going to grab E prime, which is at 3, +1. So here I'm going to go 3 units to the right and then go up by 1 unit. And then finally, I'm going to get a D prime, which is at 5, 0. So that one doesn't change either. And now I can connect all of these sections. Now remember that A prime, B prime, and C prime, that's the region where it's the parabola, the quadratic region. So here I gotta draw a curve. And then beginning at C prime, E prime, and D prime, I'm gonna create those lines because it's linear at those 3 sections. And you can see that my graph got reflected over the x-axis. And on top of that, my graph also shrunk because I had a value that was in between 0 and 1 if I'm ignoring the negative. Okay, now that I've reflected and stretched, or I should say shrinked my graph, I can do the last bit, which is just move 3 units. So I'm going to move A prime, B prime, C prime, E prime, and D prime 3 units up. So here, if I go 3 units up, I'm going to do this in reddish color. So here I'm going to go up 1, 2, 3. I have A double prime. B prime, if I go 3 units up, 1, 2, 3, I'm going to be right here. B double prime. At C, I'm going to go up 3 units, 1, 2, 3. C double prime, and again, this marks my parabolic figure, or my parabolic region. And now I'm going to reflect, or I'm going to move E 3 units up, 1, 2, 3. And then I have a linear section there. And then finally D prime, 1, 2, 3. I have D double prime now and my other linear section. So this graph that I labeled in red, that is the graph of -1/2 f of x minus 1 plus 3. So this is G.